This video goes through determining rules for graphs. The rule for the function with the graph shown is of the form y equals a e to the x plus b. Determine the values of a and b. Now we have two coordinates, 0, 6 and 3, 22. So I'm going to start with the 0, 6 coordinate. So our x and y value, substitute into the equation. 6 equals a e to the 0 plus b. 6 equals, now e to the 0 is 1, so that's a plus b. Now let's go to the other coordinate, 3, 22, and we have 22 equals a e to the 3 plus b. So we now have two equations and we have two unknowns, so we need to solve them simultaneously. I have b in both equations, so I'm going to subtract. 22 is the bigger number in equation 2, so I'm going to go 2 minus 1. 22 minus 6 is 16 equals, then we have a e to the 3 minus a, and b minus b is gone. And I can now factorize the right-hand side, so that's a e cubed minus 1. Now we want to get a on its own, so we're going to divide both sides by e to the 3 minus 1. So that means that a equals 16 over e to the 3 minus 1. Now, if this was tech active, we could go to our calculators and we could work out that that was approximately 0.84. We still need to find b, so sub a into equation 1 is the easiest one. So if we were doing tech-free, 6 would equal 16 over e to the 3 minus 1 plus b, and b would be 6 take 16 over e to the 3 minus 1. But assuming it'd be tech active, that is approximately 5.16. So therefore, a is approximately 0.84 and b is approximately 5.16. Okay, so that's our answer using the two coordinates. Could we have looked at the graph? Now, normally for a standard exponential graph, my intercept is 0, 1. So that means this point, our y-intercept has shifted up 5 units. So we have a vertical translation 5 units up. That's our b value. So I could have started with y equals a e to the x plus 5. Now what we had was very similar. We had b was 5.16, so very similar using the two coordinates. Now if I now use the other coordinate, 3, 22, to find my a value, 22 equals a e to the 3 plus 5. Take 5 from both sides. 17 equals a e to the 3. So a equals 17 over e to the 3. Now going to the calculator, that is approximately 0.85, which again is very similar to what we got by solving. So two different approaches, one using the coordinates and one using the graph. The next one, the rule for the function with the graph shown is of the form y equals a ln of x plus b. Now I'm going to start by doing the two coordinates again, and then we'll look at the graph. So 5, 0, I have 0 equals a ln of 5 plus b. So 0 equals ln of 5 plus b. E to the 0 equals 5 plus b, changing from an exponential to a log. Either 0 is 1, so 1 equals 5 plus b. So b is, take 5 from both sides. b is -4, right? We also need to find our a value. So now our equation is y equals a ln of x take 4. We have another coordinate which is 8, 1. 1 equals a ln of 8 minus 4. 1 equals a ln of 4. So a is 1 divided by ln of 4. Going to a calculator, that is approximately 0.72. So therefore, a is approximately 0.72 and b equals -4. Could we have done that finding using our graph? We don't know where that asymptote is, so we can't start with that, but we can use this 5, 0 point. On our standard graph, we go through 1, 0. So that has moved to the right 4 units. Okay, so we now have a horizontal translation of 4. Now that horizontal translation is giving me my b value. So using that information, I have y equals a ln of x. Now we're moving to the right, so we want -4. And now we can find that a value using the other coordinate, which would be 8, 1, and that would be the same as what I did there. Given y equals ae to bt with y equals 6 and t is 1 and y equals 8 with t is 2, determine a and b. So we have two coordinates. First, we have 1 and 6. So substituting that in, 6 equals ae to the b. And then we have our coordinate, 2 and 8. So that gives us 8 equals ae to the 2b. So equation 1, equation 2, best way to solve here is go 2 divided by 1. So that gives us 8 over 6 equals ae to the 2b over ae to the b. The a's cancel. 8 over 6 becomes 4 over 3. So we have 4 over 3 equals e to the 2b divided by e to the b. 2b minus b is b. So now we have e to the b. Change to a log. B equals ln of 4 over 3. We need to find our a value. So sub into equation 1. 6 equals ae to the ln of 4 over 3. Now, inverse operations. So the e and ln cancel. So now we have 6 equals 4 over 3a, solving by multiplying both sides by 3 over 4. 2 into 4 is 2. 2 into 6 is 3. So 3 times 3 is 9 over 2 equals a. So therefore, a equals 9 over 2 and b equals ln of 4 over 3. Now, what if we had technology? Determine an exponential model for. Now, we need to know if this is going to be base e or not. So I'm going to do this two ways. One way you should have done back in units 1 and 2, and the other way is finding that natural exponential. And the other example I'm going to do using the calculator is to determine a logarithmic model for. Again, are we looking for base A or base E? So let's start by regressing, which you should have done before. So we're going to go to add lists and spreadsheets. We're going to put our x coordinates in our first column and our y in our second. So we have 3.1, 4.6, 12.7, 13.8, and 19.6. And then go and put in the y values, 2.0771, 2.9028, 17.693, 22.615, and 82.503. Now it's important to now go to a completely different cell to any of that data. So I usually move across one. We go to menu, statistics, and we're doing stat calculations, and we want an exponential regression. Our first listed is X, our second list is Y, and we just go OK. So you can see our equation here is in the form of A times B to the X, where A is 1.04, B is 1.25, and our R squared is 1. So a perfect model. Okay, so that's the information we found from our calculator. So therefore, Y equals A is 1.04 times B 1.25 to the power of X. And that is our exponential model. But what if I wanted a natural exponential? So base E instead of base B, which is what I've got here. So I'm going to show you another way to do this on your calculators. So now I want to pick Add Vernier Data Quest. And when I'm in here, I want to go down to this bottom where it says a table view, and I'm going to enter my data in here. 3.1, 4.6, 12.7, 13.8, 19.6, and my Y values are 2.0771, 2.9028, 17.693, 22.615, and 82.503. Once I've done that, I want to graph it. So I'm going to pick this graphing icon down the bottom. And there is my graph. Now, I want it to be a natural exponential. So I'm going to go to my menu. I'm going to go Analyze. And from there, I want to go Curve Fit. And I want to pick exponential, but I want it to be a natural exponential. Okay, so there we have our values. Our model is in the form of A times E to the power of negative C times X, where A is 1.04, C is negative 0.223, and my R value is 1. Now, if I go OK, you can see that black curve there. That's fitting the natural exponential. So that's the information I got, which means my model is Y equals my A value 1.04 E to the now negative because it says negative C and C is negative. So that's 0.22x. Now you'll notice comparing it to our model that we found previously, there's your 1.04, which matches. Now, if we look at this 1.25 and this e to the 0.22, if you go to your calculator and evaluate e to the 0.22, you'll get that e to the 0.22 is approximately 1.25. So you can see that they're the same model. Just one base e and one base b. So now let's go and do the logarithmic model. You should be able to do the regression on your calculators using spreadsheets. So you can start doing that. Okay, so we've got X, 2, 4.5, 7, 9.5, and 12. And our Y, 11.12, 18.02, 21.77, 24.37, and 26.35. Cross to a different cell, menu, statistics, stat calculations, scroll down until you get the logarithmic regression, X value for X column, and my second column's labeled Y, and go OK, and you can see that information there. Okay, so from our calculator, our y equals a 5.23 plus b 8.50 ln of x. And that is a natural logarithm. Our r squared was 1, so it is a perfect model.